Now I will explain how to determine what type of conic we're dealing with, given its equation in general form, which would look something like this. Ax squared plus by squared plus cx plus dy plus e equals 0. And a, b, c, d, and e are just constants, so they can be any number really. Okay, and here are the little rules. We're always going to take a look at the a and the b, so the coefficients of x squared and y squared, to determine which type of conic we're dealing with. So for parabolas, a or b need to be equal to 0, but not them both. Otherwise it's going to become a line, not a circle. So what would that look like? Anything like this. Maybe it could have an x squared plus y minus 5 equals 0. I'll just give you easy examples to take a look at. So because we don't have a y squared, that means that b is 0. So we have a 0 y squared hidden there. Therefore, it's a parabola. Great. How about circles? Well, a and b must be the same. So they're equal. And, of course, they can't be equal to 0. So what would that look like? Another simple example could be x squared plus y squared minus 25 equals 0. So a and b, coefficients for x squared and y squared are the same. So it's a circle. Fantastic. How about ellipses? Now a and b can't be the same anymore, but they're going to have the same signal. So a times b will be positive, will be greater than 0. So something like 4x squared plus 9y squared minus 36 equals 0 is a good example of an ellipse. 4 times 9 is 36. 36 is positive, and 4 is not equal to 9. So those conditions are satisfied. Fantastic. Then finally we have hyperbolas. In the case of hyperbolas, a is not equal to b, and a times b is smaller than 0. So an example of hyperbola would be 4x squared minus 9y squared minus 36 equals 0. So a and b are not the same, and they have different signals. So 4 times negative 9, or 4 times minus 9 is minus 36. So that is smaller than 0. So these conditions are satisfied, and that is a hyperbola. Now I would suggest that you try a few of our questions to determine which types of conics we're dealing with, given their equations in general form. Good luck.